All right, so for a 2 column, I'm always going to start with P and Q. And then under my first few sets of P, I always start with all the information that is given. That's perfect. That's a smart way to handle it because now you have proof. And what I'm going to do here is look at my givens. I said that line 1 crosses line 2. And then under Q, that's my conclusion, right? Remember, we make that a Q. I'm just going to say that's given. And that was what I was given here. Line 1 crosses line 2. This is called P1. That's my first hypothesis. This will be Q1. That's my first conclusion. Next, I'm going to say that the measure of angle 1 is 80 degrees. No, this will only be on your 2-column proof. I'm going to turn what I'm writing into here over into a 2-column proof formally. Now, if your question is, do we have to have a hypothesis and a conclusion on every picture? Yes, definitely. Because you have to start somewhere, and that's your hypothesis. And then your conclusion is your goal. So you do have to at least draw the information that's going to be your hypothesis and conclusion. But you don't have to say, like, I wouldn't have to write that this is P and this is P. Because I'm going to show that in my proof itself by saying we assume in the written proof or right here that these things are given. And then from there I can say that, and this is where I like these better. Everything that I just did in that previous one can be done so much more efficiently here. If angle 1 is 80 degrees, I can say angle 1 plus angle 4 equals 180. And that's by the linear pairs theorem. I'm just going to put LPT. You would have to write that all the way out. And I'll do that when I type it up. If those are equal to that, then I can just say that it's very obvious that angle 4 is equal to 100 degrees. And how would I do that? I see here, I didn't have to show that I substituted this in and did all of that. My reader already knows that I have to substitute this in. If I subtract 80 from both sides, that's called the subtraction property, and you would write out property of equality. That's what you guys learned in algebra, pre-algebra, and even earlier when they say if you do something to one side, you have to do to the other. If I'm subtracting to keep everything equal on both sides, I subtract that same amount from both sides. So now, do you mean on the prompt, like what we're actually working on right now? That's what we're doing, and you'll see that they're in here already. And we're going to scroll down past that. Right now, it's just a very crude introduction to each type of proof. We're going to actually go after this, look at the examples I've written up, and then we'll go on to actually working together on ones you guys want to do. But the writing assignment document already has both of these completed, and we'll get to that in just a minute, sir. So right now, where I am is that angle 4 is equal to 100 degrees, and I can actually just follow this exact same line of reasoning, except for now say that angle 4 plus angle 2 is 180 degrees. And then, since this is P5, Q5 becomes the same as Q3 because I'm just re-following these steps. The linear pairs theorem. Q6 and P6 are going to look a lot like P4, except for now I'm showing what angle 2 must equal. And that is, again, the subtraction property of equality. I'm going to write SPO this time. Given is always P. And that is right here. If we're talking about these two given, sir, line 1 crosses line 2. When I drew that, when I took this picture that's been asked about, I had defined this as railroad as line 1 and crossing as line 2. And since they cross, I can say that line 1 crosses line 2. And that was given because I chose to add that to my diagram before starting my proof. I've also defined angle 1 as 80 degrees before starting my proof, so I went ahead and said that was also given. Given is just When you look at an object in the real world that you say, oh, I can do this proof for it, what are you seeing that tells me you can do it? And then you're going to show me from what you saw in that object how to proceed by doing P3 through P6. And now I've run out of room, but P7 I'm going to have to write. It's probably going to be even worse than normal for my handwriting. P7 is literally what we wanted to show, that angle 2 is equal to 80 and angle 1 is equal to 80. And that means for Q7, if I subtract 80 out of here, I'm left with angle 2 is congruent to angle 1. That is my whole 2-column proof. Now, if we come back up here, if we compare this apple to apples, you'll see that if you write your 2-column proof first, everything falls into your paragraph proof very easily. Here, my first hypothesis, P1, I've lost my cursor. P1 says line 1 crosses line 2. Well, we assume that happened. So there's P1 right there for us. And then we also said that angle 1 is equal to 80 degrees. And look at that. Those are my two givens. Everything between the word assume and we will show that is my givens. And then if I look here, okay, all you missed was me coming back to apologize that for some reason my internet went down. So we're back. I'm going to go ahead and start showing you how these two things are exactly the same. And if my internet goes back down, I'll be right back apparently. It looks like it erased a little bit that I did do for this, so we'll just talk about it again. So we'll start looking at this way. I said originally that my first given was that line 1 crosses line 2. All right, that's a good question. That says, if we are using this one separate from the paragraph, will we get a different picture? You only have to write each proof once. I'm just showing you both options. So if you said when I look at the vertical angles theorem, I'd rather do this as a paragraph or I'd rather do it as a 2-column, I'm showing you both so you can turn in whichever one you prefer and have a pretty easy proof to look back on. So you would pick one or the other. You would either do the 2-column or the paragraph. You don't have to do, as long as you do each theorem once, you're good to go. So don't ever double up on these because it's extra work that you don't need to do. Does that make sense? Okay, so yeah, technically all of you guys probably don't need to see the 2-column because you already have this to turn in. But I want to show you how, if I had written the 2-column first, I can turn it into this very easily. And I think the 2-column is easier to start with. Line 1 crosses line 2 is given. That's from my picture. So I would say we assume that's the fill in the blank part. This. And I have a second given at the measure of angle 1 is 80 degrees. So I'm going to include that in my given. And then we have our fill in the blank. And we will show that. And then if I come all the way down here, the very last thing that I wrote goes here because that's what we're aiming to do by using direct proof. We're always going to write direct proof on this one. The only one you may not use direct proof for is Theorem 210. But I will tell you this and put this in your notes. Theorem 210 is only graded on your work and your attempt. That is a very hard one, and that is not even fully geometric proof. That's more of an algebra proof. I just want to see what you guys do with it. So right there's 1/9 of your writing assignment. As long as you try, you get full credit. So you're already guaranteed a D on this just for turning it in. Not the best approach at anything, but I am giving you a huge cushion to help you out. I'm answering the question in the chat if my hands would work in the right order. All right. So, next I said that angle 1 plus angle 4 is equal to 180, and that's the linear pairs theorem. All right. So my vertical line here is showing both of these steps. I said 1 plus 4 equals 180, and that's right here by the linear pairs theorem. And then I did the subtraction property of equality to get angle 4 is equal to 100 degrees. Then I'm saying again, right, I did by the linear pairs theorem. So now you can see that I wrote this to be that. And I don't have to do the subtraction property of equality on a written paragraph proof because it's plain to see right here we just subtracted 80 from both sides, and your reader will know how to do that. Again, I'm going to say by the linear pairs theorem, because that is new to us, that this is true. And we can see here, I wrote on the left, angle 2 plus angle 4 equals 180, but on the right I wrote angle 4 plus angle 2 equals 180. Is that a problem? No. 3 plus 2 is equal to 2 plus 3, so I can write those in either order. And nobody will be marked wrong if they put 2 first or 4 first. As long as everything's true, you're good to go. All right. Now I have shown that I found angle 2 is equal to 80 degrees. And now I know that angle 2 is equal to 80 and angle 1 is equal to 80. So therefore angle 2 and angle 1 are the same. And that's what I set out to do. So we're good to go. And these are both done.